So first question for the Diophantine equation, which says that let n be a positive integer such that n square plus 19n plus 48 is a perfect square. Find the value of n. Okay. So whenever we are solving such questions, so what we have to do is, if this is a perfect square, let's say this is equal to m square. So n square plus 19n plus 48 is equal to m square. Now, in such question, the trick is to factorize it. And if you want to factorize it, the best thing is you should make this a perfect square. Now, this is 19n. I want to make it a perfect square. And I remember you should also remember that this should also be a perfect square, so you can factorize it. Okay. So I multiply the whole equation by 4. 4n square plus 76 plus 48 into 4. 192 is equal to 4m square. Okay. So this becomes, this is n. So this becomes 2n plus twice into 2n. 2n plus 19 whole square. 2n plus 19 whole square. And what is 19 whole square? 19 square is?
Sir, 361.
361. So plus 192 minus 361 is equal to 4m square. So 2n plus 19 whole square is equal to 2m whole square, or I'll say, because this is a perfect square, minus 2m whole square is equal to 361 minus 192. 9.
It's 169. Sir, 169.
So now this is a square minus b square. So that was the idea. So now I can say 2n plus 19 minus 2m and 2n plus 19 plus 2m is equal to 169. 169 is a square of 13. So this can be written as 1 into 169, or this can be written as 13 multiplied by 13. What else we can do? That's all. So
yes, sir.
You take 2n minus 19, sorry, plus 19 minus 2m is equal to 1, and 2n plus 19 plus 2m is equal to 168. We want to find out, so we'll add it. 4n plus 38.
1 and 169.
So why will be 168?
Okay, right. 169. So 4n plus 38 is equal to 170. 4n is equal to 132, right? N is equal to 33. So after I get n equal to 33, the first thing I have to do is we should verify whether it's satisfying this solution or not. Okay. So this is one solution. Now another is this 13, 30. So 2n plus 19 minus 2m is equal to 13, and 2n plus 19 plus 2m is equal to 30. This clearly tells m is equal to 0. And if m is equal to 0,
yes, sir,
n is actually negative. N is negative. But the question says positive integer. So n is negative. So this solution is ruled out. So what we get is we get n is equal to 33. Am I done? Am I done? Is the question complete?
yes, sir.
Yes.
No. No, it's not complete.
So we can take negative factors.
Yes, you have to check for negative also.
But
Negative
still
factor.
n will be negative.
Yes, it will not give the answer. That's right. If you check for the negative factors, similarly you will solve for this. Let's say, then you will get negative values of n. So that's another thing. But you have to always check for the negative factors. You cannot miss the negative factors. In this question, the negative factors will give the negative value. Okay. So you have to check for the negative factors. Done? So you
Yes,
move to
sir.
the pardon?
Yes, sir.
Okay.
Yes, sir.
Next question. Find the number of ordered pairs of positive integers xy that satisfy this equation. We have to find the number of ordered pairs. Okay. So this is simple. First, we'll simplify this. So 2004y plus 2004x is equal to xy, or I'll say xy minus 2004x minus 2004y is equal to 0. So x common, y minus 2004 minus 2004 common, y minus 2004. So minus 2004 square is equal to 0. So we get x minus 2004 multiplied by y minus 2004 is equal to 2004 square. So this was simple factorization, you know. This is parabolic Diophantine equation. So we know the factorization, how to do it. Now what? Number of ordered pairs. And that too of positive integers. So let me do the factorization of 2004 first. $167. Is this a prime number? You just divide it, na? 7 not divisible, 3 not divisible, 5 not divisible, 11 not, 13 not. Done. So this is a prime number. So this is what 2 square into 3 into 167. So this is 2 to the power 4 into 3 square into 167. Okay. So now what? How will you do it?
161, sir, 167 squared.
167 square. 167. Now what to do?
So we can find the number of factors of this expression, this number.
So what I want to say is you're jumping. What I want to say is this minus this is, let's say this is something like P multiplied by Q. Okay. P multiplied by Q. Then X minus 2004 is equal to P and Y minus 2004 is equal to Q, where P and Q are the positive factors of 2004 square. So, okay. So X will be P plus 2004 and Y will be Q plus 2004. This positive integral solution will always come, right? So what we have to do now? So if I see this, then how many factors are there? 5 into 3 into 3. 45 factors of 2004 square are there, right? Right, no?
Yes, sir.
We know, yes, na, if any number is P1 to the power alpha 1, P2 to the power alpha 2, P3 to the power alpha 3, then the number of divisors will be alpha 1 plus 1 multiplied by alpha 2 plus 2 multiplied by alpha 3 plus 3, right? You remember this result?
Yes,
so we
sir.
have how many factors here? We have 45 factors. So we'll have 45 solutions, right?
Yes, sir.
Now what next? Is it done? Is 45 the answer?
Yes, sir.
What about the negative factors?
Sir, but
What about the negative factor? So let's say I take a negative factor. Let's say W is a negative factor. Okay. This is negative. Let's say minus W. Okay. So if I say X is equal to X minus 2004 is equal to minus W, then X is equal to 2004 minus W. So if W is less than 2004, X will be positive. But if W is less than 2004, then the another factor of 2004 square divided by W will be greater than 2004. Will be greater than 2004. Then Y is equal to 2004 minus W and U. Then this will be negative because U is greater than 2004. But we want the positive integers X and Y. So the negative factors will not give us any solution. Is this clear?
So
yes,
can you
sir.
repeat this once more?
See, if you take the negative factors, let's say that two negative factors are minus W and minus U. So if I say W is less than 2004, W is less than 2004, then X is 2004 minus W, which will be positive number. This will be positive number. But then another factor U, because W is less than 2004, so this number is greater than 1. So overall this number U will be greater than 2004. That means the Y will be negative. But we want positive integers X and Y.
Yes, sir.
So the answer will be 45. Is this clear?
Yes, sir.
Okay, next question.
Yes, sir.
Find the value of the smallest positive integer m such that the equation this has only integer solutions. See, these are all variety of questions. Now I'm bringing in a quadratic equation. They all are different methods, right? All the questions are having different methods. No repeating methods. Find the value of the smallest positive integer m such that this equation has only integer solutions. Okay. So if this is only integer solutions, so first thing is, what can you take it to tell about the discriminant?
So it will be greater than equal to 0.
It will be greater than equal to 0 and it has to be a perfect square.
Yes, sir.
So if you say b square, that is 4 times m plus 5 square, b square minus 4ac, b square minus 4 into 100m plus 9. Okay. So this will be 4 times m square plus 25 minus 100. So m square plus 25m minus, so it will be minus 90. Minus 90m. And 25 minus 9, 16. So plus 16. First of all, it is greater than equal to 0 and it has to be a perfect square. So let me say m square, this is 4 is a square, this is a square. So let me say m square minus 90m plus 16 is a square. M square minus 90m plus 16 is equal to n square. So, okay, make this a perfect square. M minus 45 whole square. right? So plus 45 square plus 16 is equal to, no, not plus, minus. Minus 45 square plus 16 is equal to n square. What is 45 square? Can someone do for me? What is 45 square?
2025.
2025. So 2025 minus 16. So m minus 45 whole square minus 2009, right? 2009 is equal to n square.
Yes, sir.
Or m minus 45 plus n, m minus 45 minus n is equal to 2009. Now, what are the factors of 2009?
Sir, 49 multiplied by 40.
49 multiplied by 40. Not 40.
Sir,
41.
41. Sir,
40.
41.
41. So this is right. I think we have done this number before also. 2009 we have encountered before also, right?
Yes, sir.
Yes, sir.
So you remember the factors or you found out the factors?
Sir, I remember.
You remember this, okay? So this can be written as 49 multiplied by 41, right? 49 multiplied by 41 or minus 49 minus 41. So there are multiple solutions now, right? You can take m minus 45 minus n is equal to 1 and m minus 45 plus n is equal to 2009. And you can find out all the possible values of m. So the possible values of m are, if I add this 2009, so it is 1050. The other possible values of n will come out to be 90, minus 960 and 0. Okay. Now it's asking smallest. See, 0 is not smallest because again the question says smallest positive integer. So if it is the smallest positive integer, the value of m will be 90. Is this clear?
Yes, sir.
Yes, sir.
Okay. I'll take the next question. P comma Q are two integers and the two roots of the equation in x are also P and Q. Find the value of P and Q. Okay. So I'll give you a few minutes. Can you give me the answer? This is an easy question. Find the values of P and Q. let me write it. The roots are P and Q. So P plus Q is equal to P square plus 11 by 9 and PQ is equal to 15 by 4 P plus Q. Do you conclude anything from here? Before moving forward, is there any conclusion from these two equations? Is there
Yes,
any
sir.
conclusion? What
Yes,
is the
sir.
conclusion?
So we can use modular arithmetic and say P squared is congruent to 7 mod 9 and
No,
P
I'm
plus
not
Q
talking.
is
No. I'm
congruent
not
to.
talking about congruent modulo. I'm talking about the nature of the P and Q. Can I say something about P and Q? See, P plus Q is P square plus 11 by 9. That means P plus Q is positive. And PQ is 15 by 4 multiplied by P plus Q. That means PQ is also positive.
So either both are negative or both are positive.
No, both cannot be negative. No? If both are negative, then P plus Q cannot be positive.
Oh, yes, sorry, both are positive.
That means P and Q both are positive. First conclusion is this. We have to draw this conclusion here. P and Q both are positive. Now let's go and solve this equation. 4 times PQ minus 15P minus 15Q is equal to 0.
Sir, you missed plus 16.
Oh, P plus Q plus 16. Okay.
Yes.
So then I have to write it here also. So this is what? This will be 64 is equal to 64, right? है ना? ये हुआ ना?
Yes, sir.
Is
Yes,
equal to
sir.
64. Now, Diophantine equation. You have to factorize it. So if P is common, 4Q minus 15. 4Q minus 15. Then what to do here then? I need something here, na? Q common 4P minus 15. So this is giving me. So by symmetry, I need something 4Q here. Okay. So what I should do is now, I can multiply the entire equation by 4, right? So 16PQ minus 60P minus 60Q is equal to 4. $256. So now 4P common, 4Q minus 15. What happened? Minus 15 and minus.
Sir, 15.
What? What 15?
So we'll take minus 15. So we'll
Minus
take minus
15.
15.
4Q minus 15. So this will be minus 15 square is equal to 256. So what we get is 4P minus 15 and 4Q minus 15 is equal to, what is this? 15 square plus 256. So 15 square is 225, right?
Yes,
So
sir.
481.
481. Now, factors of 481. Is 481 a prime number? If not, what are the factors of 481? This is here basically ना IOQM में ऐसे numbers जब आएंगे ना, then you have to, your arithmetic has to be strong, really strong. Prime
Sir, it's
number,
divisible by 13.
it's divisible by 13. Very good. So 13 2s are 36, 13 3s are 39, 91. So 37, right? So this is
Yes, sir.
13
Yes, sir.
multiplied by 37. Now we get the prime factors. So now basically this is equal to 1 into 481. This is equal to 13 into 37. This can also be equal to minus 1 into minus 481 minus 13 into minus 37. So what are the possible values? Maybe negative values will not give us anything. We know this because one of them will be negative. When P and Q both are, no, we know P and Q both are positive. Yes, P and Q both are positive. We have concluded from here. If you are not concluded from here now, you will get the negative value of P and Q from this. So now I have to ignore these two, P and Q. Negative values. They will give me negative values. So now from here, two values of P and Q will get from here and two values of P and Q will get from here. So actually I solved it and the values of P and Q which I get is 4, 124 and 124, 4, 7, 13 and 13, 7. Now this is interesting. Only one will satisfy this quadratic equation. Okay, because quadratic equation will have only one root. And this is the answer. You can check this is the answer. 13, 7 is the answer. Okay. Clear?
Yes, sir.
So basically,
Yes, sir.
why I have chosen this question is generally we find out in the question the solutions of the Diophantine equation, the integral solutions of the Diophantine equation. Sometimes the question says, like the one I gave you yesterday, the positive integral solution of Diophantine equation. Okay. The reason I chose this question here was, one thing was this point, P and Q both are positive, which strikes you. Second is, once this portion is over of the quadratic equation and we proceed with the Diophantine equation, we get the multiple solutions of the Diophantine equation. Okay. But all the solutions of the Diophantine equation may not satisfy the original equation, which is a quadratic equation. So you have to go back to the quadratic equation and verify which solution is going to satisfy this equation. This requires a lot of arithmetic. That's the reason I have just copied down the number in my notebook and I'm telling you the numbers. And I have to verify it. Okay. So this is something, this makes this question 5 marks question. In fact, a difficult question of 5 marks because a lot of calculations are also there. Just it's not just getting by the numbers within few steps or by just some logic. A lot of arithmetic is also involved here. Is this clear?
Yes, sir.
Yes.
Okay. So you can over the class here only now for this today's class.